Hello friends, welcome to our channel. Today in part 5 of Mastering Multithreading series, we are diving into an important topic in multithreading with C#, which is foreground and background threads. Understanding the difference between these two types of threads is crucial for building efficient and responsive applications. So before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. Foreground versus background threads in C#. Thread has two types, foreground threads, which is the default one, and the background thread. And the primary distinction lies in their life cycle and how they impact the application termination. Okay, so let's start with the foreground threads. In C#, foreground threads keep the application alive until they complete their work. This means that our C# application will continue running as long as any foreground thread remains active. Okay, so you must be thinking how to create a foreground thread. So answer is very simple. We don't need to do anything specifically for creating a foreground thread. Whenever a thread object is created using the thread class, it already becomes as a foreground thread because the foreground thread is the default one. What does it mean over here? Okay, so if you see the code snippet over here, I have created a foreground thread using the thread class, and that's what I wrote. Thread fthread is equal to new thread start, and here I'm passing thread function name, which is nothing but the method name over here. By default, foreground threads have is background set to false, so we don't need to specify it explicitly. But here I wrote just making you understand how to set the value false to each background property for making the foreground thread. Ideally, we should not write it, but I have just written for making you understand how we are going to set this background property for thread as a false, right? And then finally, we need to start the thread using the start method. That's what I need to write fthread.start. It's just going to make the thread start. Okay. Okay, now let's shift our focus to background threads. Unlike foreground threads, background threads do not prevent the application from exiting when all foreground threads have finished executing. It means these threads automatically stop by runtime when all foreground threads complete. When the runtime stops a background thread because the process is shutting down, no exception is thrown in the. However, when threads are stopped because the app domain unload method is going to unload the application domain, then a thread what exception is thrown in both background thread as well as the foreground threads. We need to keep in these things in mind. Okay, so here if you see these examples, how we are going to create a background thread. First, we need to create an instance of the thread class. And that's what I have written. Thread b thread is equal to new thread start, and here I'm passing the thread function name, which is nothing but the method name. And this statement is very crucial for creating a background thread. So what I need to write it, b thread dot is background is equal to true. Basically, I am setting the thread is background property to true. That is making our thread as a background thread, right? This is the way how we are going to specifically explicitly making the thread as a background thread. And finally, we need to start the thread like we usually do with the help of a start method. So we need to write b thread dot start. Okay, so now you understood how to create a foreground thread and the background thread. Okay, let's switch to the Visual Studio and see the demo of the foreground and background threads in action. Okay, so here we are on Visual Studio. Here we are going to see the demo of the foreground and background thread, right? So for that, what I have done, I have created one console application named foreground versus background thread demo. It has program.cs file. Program.cs file, there is a class named program that has main method, which is an entry point of this application. Here, as a first statement, I am just printing this statement into console window, foreground and background thread demo. Then what I am doing, I'm just creating an instance of the thread class. That's what I have written. Thread t is equal to new thread and the print number. What is print numbers? Print number is nothing but the thread function. Okay, what is the thread function? So this is the thread function, which is nothing but the static method. What this static method is doing, it is just going to print 1 to 50 from the thread. And that's how this for statement is just going to get executed, and this statement is going to get printed. And we are making the thread to sleep for 100 milliseconds to avoid interleaving. And finally, I'm just printing this statement into console window. Thread execution has finished. That's how this print number method is going to behave. Now coming to the main program where I have written this line number 13 and 14, right? I wanted to see in the same program the foreground thread demo as well as the background thread demo. And the first statement, if you notice, t dot is background is equal to 4. So this is the explicitly a statement that making the thread as a foreground thread. As we know, the foreground thread is the default thread, right? So we don't need to mark it as explicitly as a for. What we are going to do, we are not going to uncomment this. Okay, and if you see the second statement, this statement is making sure that the thread is a background thread. But right now I have commented that because I'm just going to focus right now for the foreground thread. Okay, now what I'm doing, I'm just going to start the thread with the help of a start method. And this main method, what it is doing, it is just going to print 5 times this main thread, right, with the help of for loop group. And here also I'm just making the thread to sleep for 100 milliseconds. Finally, I have written this statement main thread execution has finished, so that it should get printed into console window. You see this breakpoint. So breakpoint, basically it is just halted this program execution. And why I put the breakpoint over here, because I just wanted to show you that foreground threads keep the application alive until they complete their work, right? So right now the main thread work is already completed, but now foreground thread still needs to print up to 50, right? Because the for loop we have written for print number, it is just going to print up to 50. So till now it has printed up to thread number 6 only. Still he needs to go and print up to 50. So right now the foreground work is not complete. So when we are going to continue over here, what will happen? This statement is just going to get printed, and when the 50 is going to hit, the program gets completed and exit the application, right? That's how it happened for the in the case of foreground thread. Now let me do one thing. Let me uncomment this line to make this thread as a background thread. What will happen? Let's see. Okay, if you see, this statement got printed. Main thread execution has finished, right? And background thread is also process some statement, right? Thread 1, thread 2, thread 3, thread 4, thread 5, thread 6. And it has to process up to 50. But because this is the background thread and the foreground thread already completed this execution, which is nothing but the main thread over here. So when we are going to hit continue button, the application is going to get exited. So the remaining work, what background thread function needs to be performed, it is not going to perform because the .NET runtime stop the application. So this background thread, whatever the work is remaining, is not going to get completed. That's how we are going to witness over. We are going to continue over here. Program got exited. So remaining work did not complete by this print number methods as a background thread. So that's the difference between foreground and the background threads in their life cycle. The foreground threads keep the application alive until they complete their work, whereas background threads do not prevent the application from exiting when all foreground threads have finished executing. Difference between foreground and background threads in C#. Okay, so let's summarize the key differences between foreground and background threads. Life cycle. When we talk about the life cycle of foreground thread and background threads, foreground threads keeps the application running until they complete their task, whereas background thread does not prevent the application from exiting when all foreground threads have finished executing. When we talk about the fundamental qualities, foreground threads are long-lived, while the background threads are short-lived. Foreground threads typically use a lot of system resources, whereas background threads are designed to be more efficient. Foreground threads have higher priority than background threads, meaning they are given more processing time, whereas background threads have a lower priority than foreground threads, allowing the application to prioritize foreground tasks. Okay, now we talk about the utilization scenarios. Let's explore when to use each type of thread. Foreground threads are ideal for scenarios like user interface, real-time data processing, network communication, GPS, and navigation. In graphical application, the main thread is responsible for rendering the user interface and handling user interaction. Any updates to the UI elements such as button clicks, mouse movement, or keyboard inputs should be processed in the main thread to ensure a responsive and a smooth user experience. When we talk about the real-time data processing, in application where it requires, such as a financial trading system or sensor data analysis, foreground thread can be used to process incoming data streams and make immediate decision based on that data. This ensures low latency and real-time responsiveness. When we talk about the network communication, foreground threads can be used to handle network communication, especially for handling incoming request and response in the web application. This allows the application respond to user request quickly and efficiently. When we talk about the GPS and navigation, mobile navigation app often use the main thread to process GPS data, calculate routes, and provide real-time turn-by-turn direction to users. In these use cases, a foreground threads ensure that critical and time-sensitive operations are executed properly, whereas background threads are well suited for tasks such as file input data processing, image and video processing, periodic task and polling, notification and messaging services efficiently. When we talk about file input and data processing, when reading or writing large files, performing data analytics, or running batch processes, we can use background threads to prevent the main thread from becoming unresponsive. For example, a text editor may use a background thread to auto-save a document without blocking the user interface, right? When we talk about the image and video processing, in application that processes images or videos, background threads can be employed to perform tasks like image resizing, video encoding, decoding, or applying filters. So this allows the main thread to remain responsive to user input. Now, when we talk about the periodic task and the polling, right? So background threads can be used for running periodic tasks such as checking for software updates, fetching new emails, or calling external APIs for data updates at regular intervals without blocking the user interface. Now, when we talk about the notification and messaging services, background threads are often used for sending push notifications, processing incoming messages, and managing messaging queue. Maintain communication between users without impacting the application's primary functionality. So in these type of use cases, background threads plays a vital role. Okay, that brings me to end of my session. To sum up, in this video, we have learned what foreground and background threads are, and then we discussed how each of them is created. Finally, we talked about its life cycle, fundamental qualities, and utilization scenario. So now I hope you must be having a clear understanding of foreground and background threads in C Sharp, and you could take a decision when to use what for greatly enhancing the performance and responsiveness of your application. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.